Hi folks, this is Calc 3, Checkpoint Quiz 4. We're asked to find the circle of curvature for the parabola y equals x squared at the point 2, 4. So anytime we're trying to find a circle, we need two things. We need a radius and we need a center. The radius, well, that's going to be the radius of curvature, r sub k. And for the center of curvature, well, we'll have to talk about that when we get to it. First thing, to find the radius of curvature, we need to take the reciprocal of the curvature. Now, there are a couple different ways to get the curvature for this parabola at this point. One thing we could do is use the cheesy parameterization. Let x be t so that y is t squared. And go through the nonsense and use the fact that the curvature is the length of t hat prime over the length of v. So it's the rate at which you're turning divided by the speed. And that's perfectly fine to go through that. Just to expose you and get you practice with another formula, which you're actually proving for your next take-home, is this formula. We can get k by taking the absolute value of y double prime divided by 1 plus y prime squared, all to the 3/2 power. And so we're going to use this formula, y equals x squared. So y prime is 2x and y double prime is 2. And if I take all of this and feed it into there, I'm going to get a formula for the curvature. K equals the absolute value of 2 over 1 plus 2x quantity squared to the 3/2, which is 2 over 1 plus 4x squared to the 3/2. So what's the curvature at the point in question? I want the curvature when x is equal to 2. So the curvature when x is equal to 2 is 2 over 1 plus, plug the 2 in there, square it, 16 to the 3/2, which is 2 over 17 radical 17. So our first piece of information, the radius of curvature, is 1 over the curvature, and that's going to be 17 radical 17 over 2. Okay, so we found the radius of curvature, so we found the radius of the circle. Now we need to find the center of the circle, so we need to find the center of curvature. And so let's think about what we're trying to do with this circle of curvature. Let me get a rough graph of the vector valued function in question here. So we got our parabola y equals x squared, and all the action here is at the point 2, 4. Remember how the book described the circle of curvature? It's a circle which lies on the concave side of the curve, so it's going to be over here, that snuggles up to the curve and lies tangent at that point. So it's going to snuggle up to it. It's just snuggling in there. And once again, my drawing isn't the best here. That's supposed to be a circle. Okay, so the tangent of the circle shares the same tangent as the curve, which means wherever the center of this circle is, the length of the radius I know is r sub k. But what's the direction? Well, the radius of a circle is orthogonal to its tangent, which means that the radius is orthogonal to the tangent vector. So the question is, what do we need to do? We need to find a vector which points towards the concave side of the curve that's orthogonal to the unit tangent vector. Well, that's the definition of n hat. So if we can find n hat, that'll tell us the direction to go. Rk, the radius of curvature, will tell us how far to go. And with those two pieces of information, we can then locate that point. So that's what we're going to do.